tutorial question is available in the Teams, just in case you're not aware. All right, we are now at the last portion of the tutorial where we talk about projectile. Okay. Now, one characteristic of projectile is we look at free flight motion. Okay, we look at free flight motion of a projectile, and we will look at the origin point, because you throw something and the object will launch at a curvature because of gravity, and then it lands somewhere. So the projection point, the starting point, we will use 0 to represent our initial point, and we'll use Cartesian plane x sub 0, y sub 0, or x naught, y naught. Okay. So for motion of projectile, we always start with a chart, y-axis, x-axis, to analyze the motion of a free flight. Right? A free flight motion, we always start analyzing using y and x-axis. Let's say we have a red dot that you want to launch somewhere. In this case, this red dot is going to launch into the air, and we see how this red dot will land. So before we started, we named the original position as x0, y0. So just recall how you plot your coordinate on the Cartesian plane. So your x0 means referring to x-axis, y0 referring to y-axis. And this one, when you see x and y-axis, we are talking about two-dimensional projectile. Okay, two-dimensional projectile. And once we have our position, x naught, y naught, or x0 sub 0, we are talking about initial velocity, v sub 0. Every time you see 0 means it's the initial, the starting point parameter. So velocity, okay, we always mark one with arrow. And again, velocity is a vector. Vector having magnitude, the length of the arrow is magnitude. The arrowhead, the tail and the arrowhead is the direction of the vector. Okay. And you know that vector, you can expand to x-axis and y-axis. All right. You know that vector that have a direction. You know that vector, you can expand it to x-axis and y-axis. Mean, if you refer to velocity at the x-axis, we use v sub ox, means initial vector in x direction. Y-axis means we will use v sub oy to represent the component of y component of our v0. Okay. Now to expand, to find the magnitude and direction of these two x and y, or oy and ox, you use trigonometry equation. Okay, you use trigonometry equation. You use tangent. You need an angle for that, and then you use tangent. Opposite is your y. Opposite is your you should see a triangular from the vector. So the y-axis, you will find the angle between the component. Tangent equal to opposite by the side, and using tangent, you're able to find the angle of the direction of the vector. Okay. All right. So this is all the fundamental concept that you learn in mathematics and also in your static module. Okay. Anyone you have problem finding the v sub ox and v sub oy? Any one of you don't know how to find the green color of y and x? Anyone? All of you able to find Let me know if you're not able to find it. Okay. Then in our module, I always use the blue color line to represent path. Okay, to represent path. Why projectile free flight motion, the path is curved? Because we're having a gravity force that is pulling downwards vertically all the time on Earth, on Earth. Okay. Okay. Let's say we have particles that fly along this path in the projectile. In the free flight motion, we ignore the air resistance. We simplify the analysis by ignoring the air resistance. Means there's no drag, there's no loss of energy. There's no loss of energy in our object. And the only force that we consider for free flight motion of the projectile from that location to that location following this curvature of path is only weight that acting on these particles or this red dot here. And we will have a constant downward acceleration. In this case, this downward acceleration is your gravity acceleration. Okay, you should know the standard value for gravity acceleration, right? It's 9.82, 9.81, right? In this case, right? So, and we are using negative symbol to represent the direction of gravity. Okay, to represent the direction of the gravity, and we assume all the direction to the left, to the right is positive, going up is positive. So that's why when we define our gravity acceleration, the direction is going down because gravity always acting downwards vertically. That's why when we do calculation later on, remember to carry the negative sign in your calculation. This will be the common error in student calculation. They know the magnitude, but they forget the direction. Okay, just take note in your personal notes there. All right, gravity for projectile motion or free flight motion in a projectile is negative 9.81. For this module, since you're taking degree level, gravity we use 9.81 and no longer 10, unless the question state use gravity acceleration 10. If acceleration value was not mentioned in the question, automatic use 9.81 for all your calculation. Okay, if you use 10, I will use question mark because value of 10 is not accurate for engineering calculation. All right. So pointing downwards, and the velocity at this point, at that particular point, or point number 2, we will use V to represent the endpoint velocity. Again, velocity is a vector form. Vector has magnitude and direction. Magnitude represented by the length of the arrow. Direction is measured from the tail to the head, represented by the arrow pointing direction. Okay. So far, these are all the important information that we expect when it comes to projectile question. We expect you to able to draw the axis. We expect you able to draw the origin position of that object. We expect you able to draw the velocity direction of that object. And remember, what is the direction of the how you draw the direction of the velocity? Velocity always at the tangent of the path. Okay, velocity arrow always at the tangent of the curve or tangent of the path. Okay, Just remember, this is what we learned before this, but you apply in a projectile. Again, since you're having a vector, you know that each vector, resultant vector, you're able to expand it to x direction and y direction. As you can see, the direction now is pointing down and to the right. Here, when you're going up, the direction is pointing up and to the right. So you should be able to draw, you should be able to sketch when you expand the velocity to x and y axis, the velocity to x and y axis. This is what we expect in your answer sheet. Okay. Then when you project down, or you can straight away use the Cartesian coordinate system. The coordinate for this location will be the x and y. Okay. So far, everything clear? I hope everything clear for you. All right. And we can connect. Okay. We can connect the origin, not original, but we can connect from the reference axis origin, where this is the origin of your x and y, with a red line or a vector, the change of location with r, because this is a curvature. Right? We can represent our position with r vector. Okay. All right. Before that, okay, this is the standard schematic diagram or standard graph that we expect when it comes to projectile question. How we give mark, or normally this one, minimum you have 4 marks for this simple graph. How do I give you marks? X and Y axis. As long as you draw X and Y axis, label X and Y with the arrowhead, I give you 1 mark. You draw the origin point, you draw the end point with the path, I give you 2nd mark. You draw the velocity, expand the velocity to y and x, expand the velocity to y and x, you get another marks. Okay, axis 1 mark, object 1 mark with the path, vector with the expand y and x, each one give you 1 mark. So it's about 4 to 5 marks for graph only. For graph only. So if you manage to understand and how to draw this simple graph, you already secured 4 to 5 marks in your answer sheet. Okay. Of course, the acceleration, this one are all the hidden information. We won't tell you that there is a gravitational force pointing downward. We don't tell you, but we assume. Maybe will help you mentioning taking the effect of gravity force in the projectile. So remember, there's a pointing downwards of acceleration using negative 9.81. R represent the location, the change of position, R. Right? Okay, just a pop quiz, not pop quiz, just a quick question. I'm not sure whether you're able to answer this one. So what happened if you drop a hammer and feather in a vacuum scenario? Well, both of them arrive at the same time on the floor. Let's say you drop hammer and feather in a vacuum, and the height of the hammer and the feather is the same. What do you think? The hammer will drop first or feather will drop first in the vacuum? What do you think, Stephen? Calling Stephen.
So fall at the same time.
Okay, drop at the same time. Okay, let's check another answer. Let's check. Sivendra, you there?
Yes, sir.
What do you think? Hammer, feather, drop first in the
Same
vacuum?
time, sir.
Same time, huh? Okay, let's watch one video. This video was taken in the Apollo mission. All right. Let's watch this video.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Okay. The short answer for this one is both of them drop at the same time. The keyword here is in vacuum. Huh? The keyword here is in vacuum. So you won't see this phenomena on the Earth. So when you analyze projectile problems, we won't give you a vacuum scenario. Huh? This is just a catch question to test whether you know this is the common logic, what happened when you drop feather, hammer and feather at the same time in vacuum. Don't surprise if you go to work later on, you attend an interview, your interviewer asks you this question. Okay, don't be surprised you have this question in your interview session. Huh? All right, so I already helped you answering that question just now. All right, so let's go back to our lecture session. So we discussed just now, how do you construct this fundamental graph just now? Let's move into equation, right? So recall that we have three equations that we discover, and three of them also known as the Newton motion equation. Three of them, they are famous as an equation to analyze motion. Motion in, right? So these three, you write it somewhere in your personal notes. These three will be very important equation for this module, okay? Because we study about dynamics, something that moves. So you cannot run away from these three equations, okay? So again, more detail about these three already covered in the previous lecture. If you're interested to know about these three, go back to the previous lecture slides and also previous video when we derive the equation for this one using the A T graph, V T graph, and S T graph. When we talk about that three kind of graph, we derive these three equations. Okay, now let's take these three fundamental Newton motion equation and the graph that we just discussed just now. Let's derive a new equation in the application of projectile. First, when you look at projectile, you look at two big components. One is in the x direction, which is horizontal motion in x direction. Another one is vertical motion, which is in the y direction. You see the particle movement in two main dimension, right? It means from the projectile diagram that you draw or you sketch, you break all the velocity vector or acceleration vector or the s vector, or not s, the s vector into x and y axis. Okay. So for horizontal motion, we look at s direction, and to the left is positive. To the left is positive. First thing to note, this is the hidden information. Because all your downward acceleration or your gravity is going down, there is no horizontal motion for acceleration to the x direction. We write a sub x equals 0. This is also another area where students will forget when they do projectile question. Okay, this is a hidden information. When you look at horizontal motion, acceleration in x direction is 0 because all the gravity will go down all the time. Take note, ax equals 0 for horizontal motion. Next, we look at the first equation that I highlight now. V equal to V naught plus AC, A sub C T means we have a constant acceleration. Then only we can use these three. These three we can only use when we have a constant acceleration scenario. So I copy the equation just now to here. How do we split this equation into horizontal motion? We will add in the x direction. Of course, here in x direction is 0, so we cancel. So for x direction, velocity Vx equal V naught x and no acceleration component for the first equation. Any question so far? Any question why suddenly Vx become Vox? Any question? Why are you able to explain why suddenly this one become Vx become Vox? Because of this one? Because we use the first Newton equation, we arrive at this one. Okay, so for projectile, your Vx, your velocity in x direction, will always equal to your origin velocity in x direction. What does it mean? If you compare this information to this diagram, this component will always same as, sorry, my finger cannot go further because of my green screen limitation. You see this green arrow there, Vox, it will always same magnitude. Okay, this is the first conclusion we get from Newton equation and the understanding of the acceleration magnitude in x direction. Second, we have clear using the first one. We look at the second one that I highlight now. What about the displacement, S? So I copy the equation to here. S equal to S0 plus V0t plus half ACT squared. You know that for horizontal motion, your AX equals 0. So here also cancel. Will give you a new equation. So your X or your final S, final position, I label it X because I refer to this diagram. X is your final location in horizontal dimension because horizontal motion only focus on X. So your final position equal to original position plus V sub O means original velocity in X direction multiplied by T. So this equation, you arrive at this one. Okay? So ask yourself, do you understand why or how you get this equation? The keyword is this one, horizontal motion. Why your S become X, refer to this diagram. Why your S0, this is a general equation, S0 become X0. S0 is your starting point. So we define our starting point in X direction is X0. So we replace X0 S0 with X0. And because we are looking at horizontal motion, V0, we're looking at V0x in X direction. Time you continue to carry forward, because time you cannot change time to X direction and Y direction. Right? Time is a time. Right? Okay. Any questions so far? Any question about this equation? Stop me if you don't understand how you get this one. Prem, you okay?
Yes, sir. Okay, sir.
Okay, good. Next, I already show you the first two equation, Newton equation. I modified according to these two. Are you able to do the third one? Are you able to guess the answer for the third one equation that will appear here? Are you able to do the steps by applying this one? This one in the equation, and do the same as this step. Are you able to guess the form of equation that going to appear over here? Copy the equation first. I copy the third Newton motion equation over here. Are you able to do the same as the previous two and derive a new equation for horizontal direction? Okay, let me guess. Let me guess. Let me ask. Nageshwaran, are you there? Nageshwaran, what is your guess? What is the answer that you guess will appear here? What will be this one? Will be this one?
V square equals to VO square.
Okay, but in x in horizontal motion in x direction, what will this become?
Vx.
Vox, right? In x direction, Vox square.
Yeah.
Plus 2, then this one?
That would be 0, sir.
Okay, 0. So this whole thing you cancel.
It's cancelled.
So the answer will be, you have 2 square there. So how you simplify the equation?
Square root V equals to
V equal to
V equals to Vox.
Yeah. Okay.
Same.
You get the same, this one and this one, basically the same. Okay. This one I flip lah, but actually the same, I think I do some typo error here. It should be VXO, but you know what is that mean, It's the original X. So basically this one and this one is the same thing. All right.
Sir, question,
Yeah.
sir.
Yeah.
It does not matter whether it's VOX or VXO, right?
Yeah. So as long as you know that this is, I put the O there to represent the original location. It doesn't matter. This is just my notation, just to let
Okay,
you
sir.
know that it is the original location.
Correct.
So in your answer, you write XO or OX also doesn't minus mark lah. I know what you mean. Okay. Yeah. Okay. So here you compare side by side. Have a maybe 10-second look at this equation, this equation, and compare side by side with this diagram. Are you able to understand what is all this mean or not? Are you able to explain Vx, Vxo, and all this, right? So basically, you try to understand the behind principle, how we arrive at this one. Basically, the main key, if you understand this one, you understand these three equations, basically you can derive in all cases. Right? You will have all these steps in your answer. You don't need to memorize. Right? You don't need to memorize. You have all this in your answer sheet. Not answer sheet. You have all this in your cheat sheet or your revision notes when you do online test later on, you have all this formula just beside you. So you just remember in x direction, your acceleration is 0. So you look at this equation, you derive based on x direction. Okay, then you'll see this one cancel, this one cancel, this one cancel. Then you arrive at the same thing. So each one of these will help you to solve. For example, the question asks you about time. So this will be the only equation that with time. So you use this one to solve for location. All right. So, and then you want to find the speed of that particular time. What you do? This is a location. This location divided distance divided by time, you get velocity. So basically, you can use this one. You do differentiation over time, you get velocity. Okay, I'll give you an example later on. But so far, try to understand how you arrive at this one, and this one. What is the reason why we can cancel this and that? That is more important. Okay, now clear yourself. Try to understand how you derive, how you sketch this one. Ask yourself, are you able to understand what are the marks given in this diagram? How you apply the Newton motion equation to derive the horizontal motion? If yes, then you can move to the next one. Do the same one for vertical motion. But vertical motion, something happened to the acceleration. Let's do vertical motion. Vertical motion, again, our reference direction going up is positive. So what about your acceleration? Your acceleration is minus 9.81. Huh? Your acceleration is minus 9.81. So again, go to the first one, copy the direction, copy the Newton equation. V equal to V naught plus AC T. Now your acceleration is minus G, or minus 9.81. You only look at vertical motion or y direction. You modify accordingly. This one, V become V sub y because you only look at vertical motion. V naught or V0, you only look at y direction. AC, acceleration, constant acceleration in going down. So you get negative G, time, copy. You get the first equation for projectile vertical motion from the first equation. You do the same for the second one and the third one. Same logic like what you derived just now. Look at the second one. Copy the equation. S equal to S0 plus S sub 0 T plus half AC T squared. You modify accordingly. S now become Y. S is the last position. It become Y according to this diagram. What is your last position in vertical axis is Y. So S become Y. S sub 0, your starting position in Y direction become Y0 according to this diagram. V sub 0, you multiply to velocity in Y direction. Time you copy because time don't have Y and X axis. Positive, half copy. Acceleration become negative. Negative, pull the negative outside. Positive become negative. Again, time, there's no direction. Time, copy. You arrive at the second projectile equation for vertical direction. Okay? Do the same approach. If you understand the first one, you understand the second one, apply the same for the third Newton equation. I copy the Newton equation. Again, velocity at the last point, velocity at the first point, 2 AC, constant acceleration. S is the final position, minus S0 is the original position. You modify on focus only in vertical Y direction. You modify accordingly to your projectile diagram. V is the last position, velocity at last position in Y direction. It becomes V sub Y square. This one is the origin velocity, but you're looking at Y direction. So V 0 Y square. 2 copy. Acceleration, in this case, Y direction is minus G. So G positive become negative. Position S, this one is the last position of that particles. Look at the diagram. Where is your Y direction in the last position? Is your Y. Y axis. Don't confuse with X. You're looking at vertical motion. So X. So your S become Y. S sub 0 means the position at the origin. Look at your diagram again. Where is the Y position? At your starting point is Y0. So S you modify become Y sub 0. You get the third one. Okay. You have 6 new equations for today by considering vertical acceleration for projectile motion. So if you're able to understand these 6, we look at example very shortly. Okay, maybe some of you is still copying. I will give you maybe 20 seconds just to copy what you see on the screen. And you look at the screen, those already copy, you look at the screen, see anything that you want to ask me, right? Okay. Next, we will look at example already. Okay, today we will look at a projectile question. Then tomorrow, we will look at a new chapter, right? Not new chapter, but in the 3-dimensional question already. Okay, no question. We go to the next one. Let's look at example number 8. Okay, read the question, for a while. If you download the tutorial, the diagram are a little bit different, but the information was still there, right? So I modified the diagram a little bit, but the information is still the same at the end, right? Okay, now we have a slider that have a curvature. You put your item and let it slide from the top to bottom. In this case, we don't interested in what happened before this point. We not interested before this point. Okay, that one fall under the chapter before this, but today we focus on projectile. Again, this question I can extend to a long question where I will start from the top there, where we talk about curvilinear motion. But today we forget about the collinear motion. We forget projectile. We start from this point onwards. Okay, so you have a set, right? Slide from the top and then reach here. This is your starting point with a horizontal velocity of 12 meters per second. I draw the vector for you, and it's a horizontal velocity. The question asks you, if the height of the ramp means this point to the floor is 6 meters, let's say this is a floor, the height of here to here is 6 meters. Okay, determine the time needed for the sack to strike the floor. Means this one, you know that you have gravity, right? So this one is going to slide and reach ground. Okay, so you need to find the time from this point to here. The range R, you need to find the range of R where the sack begin to pile up. So the set will go from here to here. Okay, what else? Let me see. Okay. So look at the question one more time. Anything that you are not sure, right? So look at the question, look at the diagram. Of course, the tutorial question that you download are a bit different. You have all the information there, but this one I split into a loss of motion here. Okay, let's start solving. First, identify your gravity. I will recommend always draw the arrow of gravity, just to remind you that when you solve projectile question, you need to derive all the vector into x direction and y direction. And your acceleration is always pointing down, just to remind yourself. Okay. Next, this is the R. What is the R that you need to find, right? So this one will do projectile, right? When it slides, it will do like this and then land here. So you need to find the distance from this location to the position where it hit the ground. Okay. Now this question is application question. If you go to the industry and you are in the automation production floor engineer, you design the automation where you need to design the conveyor belt where it can capture the product that dropped from one point to another point precisely. All right? Especially you work in the conveyor projects or automation projects where you have a robotic arm to capture the object very precisely at that particular time. Okay, this is just an illustration, but the application can be very, very wide, especially when you do this kind of free motion projectile. Okay, and we label point A as our origin, point B as our landing point. So you have your origin and end. Okay, so you have your origin and your end. And I label as C just as my datum. To measure from A to C is 6 meters. C to B is the distance that we need to find. Okay, this is just the identification where you can use to further quantify your parameter. Okay, determine the time needed. Okay, I remove the question. So we need to find the time and the R by using projectile equation. Let's start to solve. Again, this is the motion. Start your answer, or in your answer sheet. In your answer sheet, you can use your ruler to break the A4 paper into half. On the left or on the right, you start doing horizontal. On the right, you can do vertical motion. So you can make full use of the space, but I do it step by step here. So you can break your answer into two, your answer sheet into two space. Then one side you do horizontal, one side you do vertical. Recall the three equations that you derived just now. Okay, you have 6 equations that we derived just now. So we look at horizontal first. Horizontal, you have Vx equal to Vox, x equal to x naught plus Voxt, and Vx equal to Vox. Use the first one. Use the first information. So what is your information given in the question? Velocity horizontal is 12 meters per second. Basically, straight away, you already solved the first question. Vx equal to Ax equal to 12 meters per second. You just modify a little bit. V OX, you modify it to become A. Yeah? In the test, sometimes we'll give you the point. You need to write correctly your answer. If this one is A, in your answer, don't give me OX. In this diagram, there's no O there. So in your answer, don't give me OX. Don't write OX here. Sorry, my finger cannot go further. All right. So again, take note. You always need to be synchronized with your diagram. Don't blindly copy from my lecture slides and put the answer into the answer sheet. You need to synchronize the answer with the question. In this case, your origin is A. So modify the O become A. Don't give me O in your question, in your answer. If you put O, I will keep finding where is O in your diagram. Okay, unless in your answer you change A to O, then I will give you correct. If your diagram you write A, in your answer you write OX, I will put a question mark. Where is OX? Where is O? Right, I will keep finding where is O in your diagram. Yeah, first thing, this is the skill that you need. Always synchronize with the diagram. So we have the first answer, VAX equal to 12. Next, we look at the next question, next equation that you derive. You modify accordingly. X is the n position. Where is the n position from origin? R. You modify accordingly. X become R because R is the one that you want to find. Where is the origin X? Is A point. So we need to change X become A and not O. In this diagram, again, there is no O inside here. You have A. So modify O become A plus, again, your VOX. There is no O there. You need to modify VOX become VAX T. Any questions so far for second one? Okay, compare this equation and this diagram and the equation that we derived just now. Have a look and compare. Anything doesn't make sense to you, let me know. Again, I admit sometimes I have a typo error in my PowerPoint slides. Okay. Okay, so if you understand this one, we move forward. You put in the answer, R equal to XA plus you substitute VAX as 12, T. This will be the first equation for horizontal motion. Okay. Next, we look at vertical motion. Again, there will be another 3 equations just now. Okay. Recall the 3 equations that we derived. Vy, y, and vy square. And you look at individual one and apply to this diagram. The first one. Okay. I picked the second one because I have more information for the second equation. You can use the first one to derive also. Because the question later, let me see if you need to use the first one, but I use the second one first because I have the information of my y. So that's why I go for the second information first. So I have YB, I change the second equation to YB, meaning the length, the height of vertical motion. YB means the Y position at B equal to Y0 square. Y0 square means origin of your Y. So it's your A, the origin at A. And change accordingly. This one, I make it 2. Okay, I rearrange the equation already. So as you can see here, okay, oh, sorry, I look at this one. It should be this one. So VOY become VAY Again, there's no O inside here. Our origin is A, so modify accordingly. VOY become VAY because your origin is A. T copy. Then the next one is minus half AGT minus half GT. Continue. Substitute. This I would need to highlight. Your YB is negative, it's not positive. This is a very typical question where students will make mistakes. Because Y origin is at A, anything going down count as negative. Anything going up, it count as positive. So this is a very popular trap for students. Okay, I mentioned this one is a very popular trap for students. If you're not careful, you write positive here. Your YB going down, that's why you use negative 6 meter and not positive. You write positive means your rucksack is not go down, but is fly up. So something wrong with your normal logic. Your gravity pull down, so it doesn't go up. So check your equation always. Okay, so YA equal to negative. What is your YA? YA is 0 because you start from 0 here. Velocity AY. Velocity at origin Y component. You check this one. It gives you in horizontal x-axis. There's no y-axis, so that's why you get 0. If this one I modified, if this green arrow with the angle, then you will have y component here. This one is a straight x direction. You get 0 here. Okay. If in the exam, this one I tilt this one a little bit up with the angle, then you have a AY component. Using trigonometry equation, you should be able to find your y direction and x direction. If I push this arrow up a little bit with the angle, then there's a value here. But for this scenario, because your Vx is straight, then there's no y component for V. T, continue copy. Half copy. G, you know the value. Again, you are doing degree level. Don't you give me 10. Don't give me 10 unless the question mentioned use 10. You are doing degree level already. Use 9.81. Okay. In exam or test, don't give 10 unless the question asks you to use 10. For projectile, most probably we won't mention the G, but we expect you to use this value. Okay, you summarize this equation. You get the time to reach point B. Because this one 0, this one 0, you have the value here and the t square. You move this number to the left-hand side, you get 1.11 second. Again, for this module, minimum 2 decimal place, maximum 3 decimal place for your answer. Any questions so far for the time? Any question? Steven, you okay? Pranesh V Notch.
Yes.
Pranesh V Notch, you okay?
Yes.
Okay, good. Next, once you have time, go back to the previous equation. All right, go back to the previous equation. You need to find out, right? So copy the equation. You know that your XA is 0, right? Because in that position A, you start with coordinate system 0, 0. Your X at A is 0. Then 12 copy. Time, substitute this one here. And you get 13.3 something. Okay. Don't be surprised in test or exam. Maybe you get nervous. You will press the wrong number in calculator. be careful. Always double check your answer because it's too convenient nowadays. You have a loss, right? You might press the wrong number. Always double check answer. I've seen a few cases already. The step is correct, but suddenly, I don't know, somehow the numbers become very weird. Okay? Always double check the answer. Any questions so far for example number 8? I hope everyone clear with this one. Okay. Let's have a short break. Then we look at 1 or 2 more examples. Then we call it a day. Okay? We have maybe 5 minutes break. Is that all right for everyone? Is that okay? We have a 5 minutes break.
Yes, sir.
Okay,
We continue 445. Continue 445. Go for a torrid blade or scratch your arm and so on. We continue 445.